Hello and welcome. We're going to figure out, or I guess review, how to figure out how far an earthquake is away, the epicenter distance, by using a seismogram. And here we go. This blue line here represents where like a P wave arrives, and then we wait and the S wave arrives. I've given the times here, so we can copy those down. So the P wave arrival time is 8, 14, and 30 seconds. And the S wave arrival time is 8, 17, and 10 seconds. And know that we would, like on the Regents exam, they would have a line going across the bottom with like, I don't know if it's minutes or 30 seconds or 20 seconds going across the bottom to figure out exactly when these waves arrive. So I've taken some of that out, so it's not as bad. Now we've got to figure out this lag time. Why do we need the lag time? Well, eventually we're going to go to this page and we're going to figure out where these lines are a certain distance apart. We want to figure out this gap, and when we figure out that gap, we can read down to figure out how far away the earthquake epicenter is. And then to do that, instead of trying to count the boxes and figure out how many boxes up they are, because each box is 20 seconds, we're going to use this sheet of paper as a tool down here and mark off however many minutes up our lag time is, and then use that as a tool. And we'll see that in just a second. So back to here. Next thing is this lag time, and it's always S minus P because we want to figure out the difference. We don't want negative time. P is always there first, so it's a lower number. So we are going to write S arrival time and the P arrival time, and we subtract. Now, we made this a little difficult because we have to go column by column. You can't put this in a calculator because time is base 60 and not base 10. So when we say, can we do 10 minus 30 without going negative, the answer is no, so we have to borrow. We're going to borrow 1 minute from the 16, and this is a little confusing because when we bring our minute over to the seconds column, we're bringing over not 1 minute but 60 seconds. We already had 10 seconds, so 60 plus 10 is now 70. So now we can do that. 70 minus 30 is 40. Now we can do this. 16 minus 14 is 2. And so we are left with 2 minutes and 40 seconds. So make sure you write it down so you're not confused, either like this or 2m and 40s. Now this epicenter distance, we're going back to this graph, and we're looking to see where 2 minutes and 40 seconds gap is in those lines. So to do that, we are going to make a little mark at 2 minutes and 40 seconds. And we're going to, you won't have to do this at home, but we're going to group this together so that it'll slide up nicely for us. And we're going to slide this down, keeping the corner on the P line until that mark hits the S line. Getting close, getting close. That's not bad there. So once we do that, we can read down and figure out how far this earthquake epicenter is from us. So it looks like it's about right there. Each one of these boxes going across the bottom is 200 kilometers. This one is really 1,000 because we had 3 zeros on. So that is 1,000, 200, 400, 1,600. So we come back to here, and that is our epicenter distance is 1,600. Make sure you put down the kilometers. And to figure out the P wave travel time, we go back to this chart again, and now we read up. We can use that blue line that we made. This is our distance. We're coming up to here, and we go over till we hit the P line, and then we go over, and we figure out how much time that is. So that's 3 minutes, and each box going up is 20 seconds. So 3 minutes and 20 seconds is that P wave travel time. Try that again. 3 minutes and 20 seconds. So then if we wanted to figure out how far this earthquake is or what the epicenter is, we go and use this fancy thing here, and we would have to know what city we're at, but we'd open this up to 1,600, and let's rotate that down a little bit. 1,600 is about there, and let's say we had it at Wink. We'd put our center right at Wink and draw a circle. Do that 2 more times, see where they meet. That's your earthquake.